Good morning. Can you hear me? Good morning. Hello.
Hello, good morning, sir. We can hear you.
Right. Thank you. So let's start. I suppose that you have gone through the uploaded lectures, and I will summarize. Anyway, I will summarize again because this is very important. As I told you in the last week, last discussion. So product designing is very important, and when you start your research activities and when you go to start your career in any companies and developing your own initiating your own company, product designing is very important. And it is very difficult to get data through online or any books. They are not available. Some books are available, but frequently they are not available in the country. So, I propose you to go through these lectures carefully and learn something. So, but unfortunately, today also have joined 8 people. I don't know what happened. Uh, anyway, we will discuss, and others can download the lectures and they can listen, they can learn. So, in this picture, you can see a very expensive car in the world, one of the very expensive cars. You can see the price in LKR and dollars. Now the price has definitely it has been increased. You can estimate how many dollars. It's $700 million. So expensive. Uh, what is the reason for that? Right? We have cars in Sri Lanka also. We have different brands, right? Maruti, Suzuki, Toyota like brands, and German brands, Benz like and Ducati like brands. So we have so many car brands in Sri Lanka, and you know the price. You have an idea about the prices also. But nowadays we have deviated prices due to this pandemic situation, due to this crisis. So anyway, you know the prices. So what are the reasons behind that? Even in food products, there are different equal food, but there are different brands. Based on the brands, you know the quality is different. Eh? Quality is different. Final product quality is different. It is dependent. So that is the thing we have to discuss. So, you know, if we have a good product development, good plan, good prototype plan, uh, so then we can get a good output. If not, you know what happened? The output also not good, right? Then price also reduced. As an example, you know what happened to Apple. Eh? In the world, they have very good market. They have very good demand for their brands due to its quality, right? Then what happened to Samsung? Samsung, you know, the brand is there. Still, the brand name is there, but everybody talking about its speed. Ne? With the time, its speed getting slow. So those are the quality failures. So if you are going to start your own business or develop a new product, you have to have a good plan. So we are discussing in this lecture series how to do that. There are scientific ways, right? And you can see in the early morning there are some television programs how to do how to cook foods, right? That is also food preparation. And sometimes your relations may ask, what are you doing in the university? So you just told that we are doing food technology. So they will ask how to prepare this food, like questions you will have. Right? You have this experience in your homes, in your home and relation home. So they don't know what is food technology and what is food processing technology because the terms are a little bit new. So the processing technology means there is a technology behind processing. That's the meaning of these three words: food processing technology. So food processing and product development means processing means the output is different than the raw material. So almost all the processes, products, we need to have a good product development procedures. If not, you can just take raw materials together and mix it and develop a product. And finally, you can get a product. You don't know the ratios you use. You don't know the things you use and the time you use. At what time you add this such particular ingredients, you don't know. So therefore, we are talking about these product development procedures. These procedures started in aircraft engineering. You know, the things we are talking today, they are started from aircraft design. So these are all these are engineering designs. Give me a few minutes. Sorry. So this design has been started with those engineering designs, and we are going to use these engineering designs with food product development, right? And early development is very important. You know, we are doing research. We are doing. You also doing some product development for your workshops, and the research is there, concept is there, but prototype is not there, right? So when we are going to commercialize these food products, prototyping is very important. What are the prototype designs? Suppose we are going to develop a new food product or machine, filling machine, then you have concept, you have developed that one, and this is the final design, you suppose, right? But after that, when we introduce these equipment into the market, into the industry, then there will be so many issues. But nowadays also you can see some solar powered bikes, solar powered automobiles, right? There are some designs, but when we introduce it to the market, then what happens? There are so many failures. The price and its durability, its the charging time, it's all these things. There might be some problems. So therefore, early development is important, right? We have discussed two screening genesis like things. So today we are going to talk about early development. This is the third part. According to the definition, prototype is an important activity and also valuable tool in most new product development. It will help to explore new opportunities and refine existing solutions, right? And according to those definitions, there are 6 phases: definition phase, primary designing, final designing, pilot production, production phase, and use phase. So you can understand the use phase is the last one. There are 5 more phases to follow in new product development. Definition phase, primary design is there, then final design, then pilot product design. Pilot production means early development, prototype design. Then production phase. We have to clear all the errors here and go to the production phase, right? We will discuss these things in detail. And it is actually a prototype design is actually a detailed design. Can you remember you have developed, you have done some innovations for your school exhibitions, cardboard houses, and for your when you're in grade 4-5, cardboard buses like toys. Using, you have developed a detailed design using a different raw material, because the original, when we are going to develop a car, it is high cost. Then what happen? Then what we can do is just take some raw materials, low cost raw materials, and develop. Construction කරනකොටත් අපි කලින් model එකක් හදනවා. That is prototype design and analyze the errors, right? What type of errors do we have? It is actually a detailed design. All details are there. If it is a vehicle, steering wheel is there, lights are there, engine is there, all these things are there. Now we have good market for these prototypes. You can see in some YouTube channels and medias, you can see there is engineer in Colombo who is developing train designs. Kochi had the prototype design he has developed and market. So very high cost. You also can do such job, such business. You can actually develop some food processing machines, small scale, and sell. This is actually a very good market. Very small buses and small cars using a different raw material, and you can develop a detailed design. It's a type of detailed design. Normally call it as a prototype design. Major objective of prototyping is to determine whether the design is feasible or not for further design, right? Modifications are possible. So these things you can understand. And following functions will also be conducted in prototyping. Methods, finding of methods and machines. So if it is a food product, then we have to find the method, proper method, and machines. If it is a yogurt, so we should have a chilling machines and mixing machines and filling machines and incubators. All these things are there. Then find which type of machines are we needed and its specifications. Designing and purchasing tools also important. Selection of suppliers, right? You can get the suppliers, you can register the suppliers and get their samples and develop your product with these samples and analyze what happened. And planning of inspection and quality parameters also have to be finalized. In this yogurt, you have developed the prototype design, this yogurt, and what are the quality parameters? How to measure the strength of the cup, plastic cup, and pH value and color. All these factors you have to decide and initiate its parameters and limits. Then everything is there. Now you have completed all these things. Then you can directly go to the market. Directly you can market your product. If not, you just prepare some formula and send to the market. Then there will be so many issues. After that, you are going to develop. That is wrong. Before entering into the market, you have to do all these things. Okay, suppose you got those things I explained. So prototyping is very important in your future activities. Please follow the prototypes, right? Then we are moving to very important thing, experimental design. This is the heart of these lectures. It is very important how to decide, right? Then as we discussed earlier, then we just an example for a cup of tea. We have the 3 ingredients: boiled water, then sugar and tea. So there are 3 ingredients, 2 ingredients. Basically we use water. Then 2 ingredients, you can develop a range of tea by altering its sugar value, its sugar amount, and tea amount, right? The first cup of tea, you have used 2% sugar, and we maintain the water and tea level as constant. Then the second cup of tea, you have used 3%, third one 5%. Likewise, you can develop a series of tea and taste it. Then again, there is another factor, tea. Then you have to maintain the water level as constant, and then sugar level you have selected as 3%, then it is constant. Then you are altering the percentage of tea to 3%. So how many experiments do we need to find the best product? Only we have two factors to be changed, but how many experiments do we need? And for value addition, we are going to add some ginger. Then again, we have a factor. If it converts into milk tea, then we are going to add some milk. So another factor is there. So you have to do around 100 trials to get the best formula for tea. So that is difficult. Then so therefore we are using experimental designs in developing food products. This is actually, as I explained earlier, engineering design. So actually nowadays we can do these experimental design using statistical softwares. We will discuss these things later. And experimental design is a process of planning a study. To meet the specific objectives. Planning an experiment is very important. You know, planning is very important, not in experiment, in your life also it is very important. And it is reliable. Sufficient sample should be there and taken. There are several ways to do experiments we will discuss. And an experiment might have just one independent variable, or it might have several. As we have discussed in the tea example, there might be one factor or different factors, right? And the objectives of experimental designs are to determine which variables are most influential. So what is the most influent one, right? And determine how and where the influential levels. So we'll discuss, you can understand later. So find the optimum value is different, right? Difficult, because uncontrollable factors are again there. You know, when it comes to yogurt example, humidity is there, okay? And microbial levels are there, and light levels are there. So there are controllable factors and uncontrollable factors. So therefore, it is important to have experimental designs. In experimental design, we can check 2 or more variables simultaneously. But in the first example we have discussed, tea example, and for that example, let's say we have to maintain 2 factors as constant, and 1 factor we are going to change. But if it is so when it comes to experimental design, we can check 2 or more factors together simultaneously, right? To get ambiguous results by performing small number of experiments, we have to use very small number of experiments, but we can get good results, reliable results, and materials and time devoted, and the investigations are reduced. Only way to detect interactions, right? It is important. So the first tea example, we just maintain 2 factors as constant and change 1 factor. So how to check their interactions? There is no way to check their interactions. But in experimental designs, we can check all the interactions. It means we are going to change all the factors simultaneously and check their interactions. What happened when we put 2% milk and 1% sugar, right? Then what will be the flavor, right? So we can do such experiments simultaneously, right? Significance of main variables and traits can be estimated, so we'll discuss. And there are 2 statistical designs, sorry, principles in statistical experiment, replication and randomization. Replication is very important in research. You know what is replication? Replication means repeat, ne? Repetition. Medical replication, right? Replications, the means to get one reading, we are doing 3 experiments. Ne? We get 3 results and get its medium value. So if it is a postgraduate degree, we have to get 6 results, at least 6 to get the result, right? And randomization, you know what is randomization? We are going to select samples and design randomly. So these are the 2 principles, replication and randomization. So just remember. And in experimental designs, we can do a blocking. What is the blocking? Suppose you have 25 members in your batch. Then I'm going to divide 5 groups. So finally, you have 5 members per group. There are 5 groups. Then I will ask you to develop a food product, similar food product, right? So same one. As an example, spicy chocolate with spicy taste. So I will provide all the simple ingredients, all the similar ingredients to each group and give them same time, 5 hours, and ask them to develop. My product is spicy chocolate. Ask them to develop the same product. And what happened? Finally, what happened? There are 5 groups. Raw materials are same. Objectives are all these things are similar. Environmental conditions again similar. Methods are similar. But there are some biasing effect. So there are some different interactions. Not interactions, we call it as biasing. In one group, they are planning to do, they are planning to add spices after boiling and molding. But other people, they like add the spices while it is boiling. Right? There are some deviations based on their requirement, based on their experience might be. Groups හදන්නේ මේක ක්‍රම 5කට. එතකොට එතන you know there is a bias. A group member කෙනෙක් සමහරට කැමති වුණොත් එතන එක වෙනස් වෙනවා. ඒතර bias එකක් එතන තියෙනවා. So we call it as biasing effect. So we can block bias using this. Okay, I will do using this experimental design. Randomization means random order in which the runs of experiment are to be performed. In this way, the conditions in one run neither depends on the conditions of the previous run or not. Predict the condition in the subsequent run. It means, as I told you, in experimental designs, we can do different test methods, right? We can do different test methods, right? Here you can understand in this way, the conditions in the run neither depends on the condition of the previous run nor predict the condition in the subsequent run. Can you remember COVID testing? How to do this? First, they got samples from the society. Random samples they got. Can you remember random samples? Regular bus stand, station, school, government, random samples. Right? That is randomization. And analyze. Replication can if some person tested positive, then they are doing 2-3 tests to confirm it. That is replication, right? You just need to remember what are the differences. We do randomization. It really is, you can understand these things with the examples we are going to discuss today. So I just wanted to highlight here is what are the difference in between replication and randomization. So we can do these things by using experimental designs, statistical experimental design, right? Suppose got it. Okay, so we can block it, block the bias effect. And here my theme in this lecture series for cars. So you can see Bugatti car, and the cost is there. Bugatti, you know, it is one of the very expensive cars and very popular brand in the world, right? $187 million. So it is very difficult to convert as well into rupees. Right? Okay. So we are moving to one factorial designs in early development. So one factor experimental design. I have discussed with you this one factor experimental design for the T example. Right? Several raw materials and processing conditions are normally considered in developing food products. Several variables are there. In this method, only one variable is changed at time. We are going to change only one factor at time and test it at several levels. Right? We have this, as we discussed, only sugar. We are going to change only sugar percentage, and we are tested at different levels, 2%, 3%, while holding the other variables as constant. Right? Find the optimum level we are taking. You know what is optimum level for tea and sugar, and you can get the results, right? As I in this picture, in this graph, you can see temperature and specific volume. So they have taken different samples. This is the optimum value. What is the optimum temperature for this specific volume? 30 degrees of Celsius. This is taken from using one factor method. Then another example, specific volume and time, 120 minutes. So we have to take this specific volume. You know the time is 120 minutes for at 30 degrees of Celsius. So two types of experimental experiments have been performed, and there are some replications. But unfortunately, you can see the optimum value. They have taken, can you remember? 30 degrees and of Celsius for 120 minutes. It means 120 minutes, 30 degrees. So according to this one factor method, optimum is there. This is the optimum value. Forget about the graph. This is the graph taken from statistical software. Forget about the design, and you just want to understand. As I explained in this example, optimum temperature, they have decided as 30 and time as 120 minutes. But what happened again? This is optimum taken from this experiment, but this is the true optimum. True optimum is not equal to the optimum obtained by one factor method. The reason is interactions. Can you remember, as I explained in the first few slides, with the T example, we can change and we can find the conditions, right? We can find the optimum values for particular raw material, but that is not the true optimum. Why is that? We can't observe, we can't take the reactions of interactions. There are some interactions. Fruit pickles are very popular. So we just add some sugar and salt, right? sugar and salt. According to the procedure, sugar level is 2 and the sugar level percentage is 2, might be 2 and salt might be 10. But when we put some 2.5 and 10.5, 9.5, you can get a very good true optimum. It means true optimum. Okay? So අපි ඔයගොල්ලෝ ගෙදර කෑම හදනකොට true optimum එක ගන්නෙ by experience නේ. Just taste it and add some salt and taste it, add some milk, right? We are doing. But in experimental designs, we can get the true optimum by using statistical softwares, right? I think you understood. So the disadvantages of this one factor method is it is more samples should have to be conducted, time consuming, high cost. We can't identify interactions, and large number of trials have to be conducted. So loss is there. So suppose you are going to suppose it is a food products. So raw material wastage is very high. Ne? It's directly affects on food security also. And quality of the food product cannot be described quantitatively. We can just say this is high, very taste, very good, but we can't analyze it quantitatively. Got it? Therefore, we are moving to the statistical food product designs and factorial designs, right? How is that? Again, 176, right? So, in the statistical food product designs, right? The demand for new food product and for high quality requires extensive and use-effective statistical experiment approaches by engineers and scientists. In the past, such as extensive use had been hindered due to lack of proper training. So those days we don't have training and computers had hardwares and softwares, but nowadays we have very good hardware systems and computer software. So we have to just put feed data and get designs, right? So in this experimental design, we can observe the interactions and also effects. Interactions and effects are different, right? So by using the statistical design, we can get effects and also interactions. So therefore, the statistical food product designs are efficient. Because why is that? Several variables can be tested together. We can change sugar level and the tea level at one time at different levels. Interactions are possible. Effective information can be extracted using few trials, right? Response at all possible combinations can be studied. Graphical and summarized data summarization also there. So those are the advantages. Here we are going to plan experiment scientifically, right? Scientific design is there. Then you can use this design for your research and any project. Often we use experimental data in food processing and also other engineering designs. Several factors can be tested simultaneously, right? So these are the things. The first one is factorial experimental designs, right? If you have any doubt or question, please ask. Now we are moving to factorial experimental design. Each slides have a combination relationship. So if you miss one slide or one theory part, then it will be difficult to get the idea. So if you have any doubts, please ask your question, right? In your exam, you have practical questions, how to apply all these things together in designing, right? Okay. Then factorial experiments. So one question. Can you explain previous slides? So no need to explain this one. No need to explain. You just read. Factorial designs are normally used to plan experiments scientifically. It's simple. And this is one of the most often used experimental designs. Two or several factors can be tested, analyzed, designed simultaneously. In statistics, a full factorial experiment is an experiment whose designs consist of two or more factors, understood, each with discrete possible values or levels, and whose experimental units take an all possible combinations of these levels across such factors. It means you can test all the factors, or if you require one, two, having what do you call lower value, ඔයාලට සම්පූර්ණ ටික කරන්න පුළුවන්, ටිකක් කරන්නත් පුළුවන්, but in design you can get the entire design. So I will show you some examples, right? Okay, this is the design, factorial experimental design. Here, if there are m levels for each factor of n factors, the design is there. M levels factors. What are the factors? For T sample, factors are the conditions that we are going to change. So T is a factor, sugar is another factor, and if you need, then we can change the water temperature as well, or we can add right. We can add some. We can check for other raw metals as well. So factors means the conditions of raw materials. Levels mean at what level we are going to measure. 2%, 3%. It means two levels. Sometimes we are going to we have to check it at 5 levels. 10%, 20%, 25%, likewise 5 levels. So if there are m factors, m levels, and n factors, we are going to check at m levels. So a number of experiments are there. For an example, 2 factors at 2 levels, then 2 factors at 2 levels. So how many trials should be conducted? Only 4 trials. 2 factors, we are going to check at 3 levels. 2 factors, 3 levels. Then 3 to the power 2. It means 9 trials have to be conducted. Got it? So, depend on our factors and levels, we can design our experiment. This is a scientific design. Right? Very simple. Example, raw materials, sugar and wheat flour. The levels, 2 levels. So it means there are 4 trials. It means 2 rows and 2 columns. Right? 2 rows, 2 columns. Then altogether 4 trials should be conducted. This is the example. Give me answers, right? How many trials have to be conducted to select optimal levels of raw materials in developing a new food product consists of 3 ingredients such as 1, A, B, and C at 2 levels? Give me answers. How many factors are there? How many factors are there? 3 factors. How many levels are there? 2. So let's say, please give me answers. How many trials we have to conduct? 8 trials. Yes, great. How many trials? 8 trials. So how to design it? How to design it? Ne? There are 3 factors. Minus 1 and plus 1, 2 levels. It means minus 1 means 5%, plus 1 means 10%. Then if you are interested, you can use 1 and 2 or 5 and 10. That is based on your requirement, right? If 5 equals minus 1 and 10 equals plus 1, this is the design. You can practice it. Okay? Practice very simple design. There was a question how to design levels, how to decide levels. So it means levels means it is actually we can't decide based on your requirement. It will there. So you are going to check the based on your requirement. You are going to check its quality with different levels and different ingredients. So already levels are there. The levels can you decide කරන්න බෑ හැබැයි ඔයාගේ experiment එකේදී what levels decide කරන්න වෙනවා. Right? Right. I think you all understood. Questions? Any questions? Right? These are the 8 designs as we have discussed in the previous slide. Minus, minus, minus. Right? Then we can draw this diagram, graphical description. Right? This is the graphical representation. Then you can see the first design, minus, minus, minus means this one. Then the second one, you can see. Likewise, you can place these values in these corners. Right? There are 8 values. You know there are 8 corners. And you can draw this diagram. And likewise, you can see get the center. This is the optimum level. Right? We call it as true optimum level. Understood? Right. There are 8 trials, and this is the optimum one. Exam right? You need not to remember. You just practice how to write these things. You can make it then you can draw this diagram, any diagram at any time. Please practice this with different examples. Change the levels and practice. Right? You know my style, so you never expect such questions, right? Okay. Then factorial experimental designs means all factors are varied simultaneously, and 2-factor and 3-factor designs are there. We have already discussed 2-factor methods, and another design is 2n minus p design. We call it as fractional factorial design. What is the why are we going to use design? Here you can understand we have to do 8 trials for 3 factors at 2 levels. Now if we can reduce the number of trials, that is better. Trials that is much better. Then again there is a method called fractional factorial design, also known as half n design. 2n factors design was modified, more requirement, more interactions we can observe. required minimum trials, how to do these things we can discuss. And different kind of designs are there in the Statistica software. But basically for food, in this stage, we use P as 1. Please remember, in basic food processing designs, we use P as 1. Right? Then other factors are similar. Then you can, in this example, he has developed a RTS drink. How many ingredients? Ginger, lime, cinnamon, pepper, and garcinia. Right? How many levels? There are 2 levels. So if we have conducted 2-factor factorial method, factors 2 levels 5, sorry, factors 5 levels 2. So we have to conduct 32 trials. Right? You have to develop at least 32 samples to get the best one. But when we apply this 2n minus p design, half factor factorial design, or fractional factorial design, then 2 and 5, as I explained, p is equals 1 here. Then how many designs? Only 16 designs. Then almost half, neither. So now you can use 2n minus p or fractional factorial design. So you know these things now, how to reduce the samples and get more interactions. Right? Clear? Right. And how to write these things, you can see the 5 ingredients and how many trials? 16 trials according to the n minus p fractional design. And in green color, you can see the minor level, and plus yellow color, you can see plus level. It can be -1 green color, +1 can be yellow color. You can see what is denoted by -1, 2%, +1, 5%. If you are interested, then you can use 2 and 5 for -1 and +1, no problem at all. minus plus so here you can see interactions. Let's say the interactions here. In this, there are 5 ingredients as we have discussed. In this column, you can see what happened. -1 means x1, this one multiplied by this one and this one. Minus minus plus, +1, +1 multiplied by -1, the result will be -1. Here again, minus minus plus, plus minus minus. In here, 10th one, plus minus minus, minus minus again plus. So interactions are there. Interactions can one the method of design relationships as a result of these interactions. But in factor method, the 1-factor method and other factor methods we have discussed up right now, they don't have any interactions. But here you can see interactions. This is only one example, right? You can observe some other interactions as well. It means we can observe some interactions using fractional factorial methods. So how to design these things, you don't want to remember how to write minus plus here. It's a little complex. You can just download these things from the internet, and there are some statistical software. I will show you how to get these, how to do these things using Minitab, right? How to using these things using Minitab. Then you don't want to remember for the first minus, 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 like that we don't need. Right? We're going to make a practice karana pulan. This is very similar. You better to practice this one with different examples, but don't try to remember this fractional method. It is little complex. Understood? How to get the interactions here. right? All these are experimental and statistical designs. You just want to identify the interactions and levels and how to develop the sample. Now you might have question. කොහොමද අපි මේක තීරණය කරන්න කියලා ඔයගොල්ලන්ට question එකක් ඇති. අපිට මේ සිනමල් ginger තියෙනවා. ඇයි අපි මේ දෙකම ගත්තේ නේ? So you have to perform some experiments. Right? Basically you can do if it is a porridge. අපි කැඳ එකක් හදනවා නම් you know the water percentage we know by experience, or we can refer some literature. The water to grain percentage is 70 to 30, like the percentage there. Within the limit, we are going to apply these factorial designs. It can make up then අපිට මේක අර එක සැරේට හිතෙන් පහළ වෙන්නේ නැහැ නේ මේ percentage එක levels එක by experience. ඔයගොල්ලෝ අන්තිම level එකට ගෙනල්ලා මේක by experience you have to do some trials, basic trials, and find the optimum for your optimum. Basically we use this type of water and rice and just boil up to this extent. To fine tune to get the proper one, we are using this statistical design, right? If not, you can use this statistical design again, no problem. But basically we just refer some articles, and by our experience we have to develop the product. Then as an example, beverage එකක් හදන්න යනවා. එතකොට අපි මොනවා හරි මේ powder form එකෙන් තිබ්බොත් නැත්නම් solid form එකෙන් තිබ්බොත් ඒක definitely we have to dissolve it නේ. We should have a common sense. If not, we can't use solid directly. Non-dissolvable, so dissolving property also should be there, right? So we are using experimental designs to finalize the sample, right? Right? Just for experiment. Then the third one is 3 factorial design. What is the meaning of 3? Here we are talking about 3 factors. Still we have discussed about 2 factors, but now you can go for 3 factors. Right? Here you can see the design, and let's discuss with the 3 variables at 3 levels. So 3 levels around -1, 0 and plus. Right? Or your values. Here 3 variables are there, 3 raw materials, x1, x2, x3 at 3 levels, -1, 0 and +1. Then how to write the designs? So 3 to the power 3 means 27 trials which you have to conduct it, right? 27. Then this is the design. So you can see 27, right? Minus. Likewise, this is the design you don't want to remember, right? And the graphical representation here. And how to get the optimum value here, you know. I will show you another example. Can you see this screen here? You can see how to get the 27 trials. As we have discussed in the previous example, these corners are there, right? How many corners? 8 corners, and middle of these 2 values, right? So these 2 values middle you can see, right? 1, 2, 3, 5, 6, 7, 8, 9, 10. Likewise, there are 27 trials. Right. 27 trials are there. So corners. In the first example also we have discussed corners, first 8 minus and starting from 3, all these variables are low levels. Corners, you can see this symbol 1, 2, 3, 4, 5, 6, 7, 8. Then we can observe border middle points in this mark, square shape mark, triangle shape mark. You can see how many marks? 1, 2, 3, 4, 8, and 12, right? How many combinations? 12 combinations. Then last 8 for surface center. The star mark, you can see surface center. එතකොට මේ values දෙක අතර එක අපි මෙතන ගන්නවා. ඊට පස්සේ මේ value මේ values අතර එක අපි star වලට ගන්නවා. Star වලට අරගෙන ඒකෙත් optimum එක අපි ගන්න. ඒතර මේ optimum එක is very correct. And so many interactions you can see. Right? So many interactions. The මේ දෙක අතර interactions අපි මෙතනින් බලනවා. ඊට පස්සේ මේ හතරම අතර interactions සහ මේ හතරම අතර කියන්නේ මේ අපි මේ ගත්තොත් 1 2 3 4. ඒතර මේ interactions අපිට මේකෙන් බලන්න පුළුවන්. Then මේ ඔක්කොම අතර interactions අපිට මේ surface එකෙන් බලන්න පුළුවන්. Then again we can see all interactions, 27 interactions from here. So we can observe all the interactions by using this graphical design. Questions? Do you have any questions? Right. Okay. Then mixed factor factorial designs are there. Right? We have discussed 2 factors. We have discussed 3 factors. Now we are going to use all these factors together. We call it as mixed factor factorial design. The support for both linear effect and quadratic effect. Forget about these meanings, statistical words. Linear effect and quadratic effect, right? I will discuss these words with the Minitab examples, right? Reduce trial numbers. Now you know the first one, we have to use more trials. Then in the second method, we have reduced number of trials up to almost half. Reduce trial numbers to determine the relationship between all the independent variables and the food quality objectives. Here we can use how many factors at n level and 3 factors at m level, right? So for example, if there are 2 factors at 3 levels and 1 factor at 3 levels, then you can use, at least you have to do only 12 trials. What are the objectives of having this mixed factorial design? ඉතින් අපිට මේක ඕනේ. ඔයගොල්ලෝ ප්‍රශ්න ඇහුවේ නෑ නේ මේකක් වගේ. දැන් බණහනවා ගහන් ඉන්නවා තේරෙන්නේ නැත්නම් අහන්න, right? එතකොට අපිට ඇයි මේ දෙකක් එකට check කරන්න ඕනේ, right? Then we can check 2 factors using 2 factor methods, 3 factors, 3 factor method and get the results. So what is the objective of having this mixed factorial method? Can anybody answer? Give me suggestions, ideas. අයියප් මේ දෙකම එක සැරේ පාවිච්චි කරන්න. Very good. Very good. We can check the processing conditions and raw materials together to reduce the examples. Very good for your answers, and thank you for your answers. Very good. So we can use processing condition with example with raw materials. As an example, let's imagine about ice cream, right? The basic raw materials are milk and binding agent and the flavor. 3 factors. And the processing conditions, aeration limit is there and temperature is there and mixing patterns. Likewise, there are different processing conditions. So here we can test different processing conditions plus raw materials combinations. If there are 2 factors at 2 levels and 1 factor at 3 levels, it means 2 raw materials at 2 levels and temperature at 3 levels. We can check how many trials do we need to perform, only 12. And this is the design. Right, here also you can see first 8 corners and stars also you can see, and the effect is there, and get the optimum value here. Optimum value means what are the optimal raw materials and processing conditions, right? You got it? Yes, I will explain it again. Here, ඔගොල්ලෝ හිතන්න අපි යනවා තේ එකක්ම හදන්න. Just take the very simple example. You know the basic raw materials, tea and sugar. And here we can check the temperature of water as well. 2 factors at 2 or 3 levels. We can change the sugar and tea at different levels together with different temperature water. 60 degrees of Celsius, 90 degrees of Celsius, and 100 degrees of Celsius. Right? Or time. Right? Different factors, processing conditions, and raw material conditions together. Clear? Malind? Is it okay? Or do you need further explanation?
So could you please explain it again?
Huh? Okay. Oh, explain it again.
So can you explain it again?
තේරුණා නේ? මේ දැන් ඔයගොල්ලෝ තේ එකක් හදන්න යනවානේ. තේ එකක් හදන්න යනකොට තේ සීනි අපි පාවිච්චි කරනවා වෙනස්. දැන් අපි එක්ස්පෙරිමන්ට් එකක් කරන්න යනවා. තේ ප්‍රමාණයත් අපි වෙනස් කරනවා, සීනි ප්‍රමාණයත් වෙනස් කරනවා. But one factor method එකේදී අපිට එකයි වෙනස් කරන්න පුළුවන්. Now for 2 factors we can change 2 or 3 factors together, right? එතකොට අපි යනවා එකම වෙලාවේ එකම process එක අපිට කරන්න පුළුවන් තේ ප්‍රමාණයත් වෙනස් කරලා සීනි ප්‍රමාණයත් වෙනස් කරලා ඒ වගේම අපි ගන්න වතුරේ temperature එකත් වෙනස් කරන්න පුළුවන්. Then there are 3 factors and different levels. That is we call kind of different නේ. The raw materials උයි දැන් ඔයගොල්ලෝ product එකක් හදද්දී factorial designs වල normal 2 factor and 3 factor වලදී වෙනස් කරන්න බෑ. දැන් ඒ කියන්නේ factors කියන්නේ එකම දැන් raw materials with temperature දෙකම එක හැර වෙනස් කරන්න බෑ. Right? If you are going to change raw materials, only raw materials. Right? If you are going to change processing conditions, only processing conditions. But here mix. Right? You can use raw material and as well as processing conditions. That is the difference. And you can observe the interactions here. And then on.
Okay, sir, I got it.
Right. Great. So, so we have to learn a lot. Then, any questions regarding this session? One of my examples, I have used different examples with different themes. Then you can remember this picture with these examples, with these things. For factorial design, this car and this car, that was a black car, and we learned these things under black car, and that was a blue car. and the color also blue. So we learn a lot use under blue car. Likewise, you can remember that's the reason for incorporating pictures here. Right? Okay, then අපි ඊළඟ lecture එකට ගියොත් ටිකක් boring වෙන හින්දා so I am moving to the different talk, right, about colors, right? මතකයිනේ අර දේවල් දැන් we are moving towards a different topic නේ. It is a very interesting topic. You have learned something about colors. Therefore, I am not going to explain in detail, right? Under food physics and food physics also you learn how to measure color. So, and Dr. Lasanti also discuss with you. So I will explain a little bit about colors, right? Then there are some other designs we have to discuss, but today I hope that you earned a lot. Then we can discuss the orthogonal designs another day, right? Okay, you know, colors are very important in new product development, right? And when we look at a food product, color, then what we observe, what we can feel, you have this experience, right? Food colors are very important. Here we have 3 colors, right? Here we have 3 burgers, 3 different colors. So what will be your selection? Okay? When we if it is a black one, you feel sometimes a rotten one, it's not good, like some feelings are there with this black example. It's black, it's rotten one, it's not good, it's local one. When you think about this one, is a very good one. I can guess this one is also not good. I think so, but your feelings are different, your observations are different. So that is why color is very important. It's the first quality parameter. You can just all these things. You can imagine so many factors by using color. So therefore, if we are going to develop a new food product, you have to think on its color, right? And the live example here, you all have this experience. When you go to the market, fish market is there, then they use lighting conditions, fluorescent light you can see, not CFL bulbs. So what is the reason behind that color, right? To enhance its color. They think that the color will add about its freshness and flavor. And sometimes when you go to the market, you can see when you go to the polar market also, they use sometimes a red light for onions. You can see they have covered the places they are selling onions red color cloth, right? And when you go to Kiehl's also, you can see they use a green color for their some food products to get the attraction of the people. So therefore the color is very important in determining, in developing food products. Here you can see 3 examples. Then I'm not going to explain. For the first example, you can see sometimes we are going to roast bread. So with different processing conditions and experience, you can get different colors, right? You might have this experience sometimes. So In strawberries, you know, the red color is the prominent color, and there are some other color strawberries are possible. We can develop, but what happened to the when we introduce it to the market, then what happened? And apples also there, different colors are there, so different people prefer on their colors. So we are talking about colors because it is the very important quality controlling tool. We can imagine the food quality using color, right? Quality control, quality index measurement of raw materials and determine the conformity of food quality to specification, analyze the quality change as a result of food processing, denotes overall quality of the food by the color, right? You can read and understand, right? You can read and understand these things. Why are we using colors? And we use color classification. We are talking about color classification today. How to quantify colors, right? How then before that we have to learn the what happened when we put a food product under sunlight, then we see some color. We can observe a color as a result of light reflectance. If it is a black color, it means it absorbs all sunlight. If it's a white color one, you know, full reflectance is there, right? So therefore, foods have different visual qualities, and texture and viscosity also significant, like measure. So based on these characteristics, we are going to categorize food into main three categories: opaque foods, translucent food, and transparent foods. So opaque foods means 100% reflector is there. I can make a transparent opposite word. Then when you take an orange or an apple, you know, light waves not moving through the fruit. It means it's a opaque one, right? Only reflected light, 100% reflectors is there. These are some example. Most probably food metal with thickness about 5 to 20 millimeters. So podi ganakam unot take current light yande. These are some example. But the important thing is we use geometric sphere-based technology to measure the color. You have familiar with these technologies in your food physics, so I'm not going to explain. This is the theory of geometric sphere-based technology. You just read. I'm not going to ask questions from these slides. Just put for your knowledge, right? What is a geometric sphere-based technology? So we use this technology to measure the color of opaque foods. Can you? You can see how sample is there, a light source is there, then reflect the light, and spectrophotometer we can observe, right? The weaving angle is 8 degrees. You can see the alpha, it is 8 degrees. Right? Then translucent food means partially reflected and partially transmitted. Right? These types of food can vary in levels of transparency, which alters the amount of light that passes through the sample and may change the direction and the angle. Fruit juices, jams, jellies, you know, those are the translucent. The light source is there, the reflectance and diffusion. Half, 50% reflectance and 50% diffusion. When it comes to transparent foods, you know the meaning. Transparent is 100% diffusion. No reflectance is there. Right? These color classification rely on light transmission. Food are measured with 45 degrees. So we can use spectrophotometer to measure the color. So this is a summary: opaque samples, translucent and transparent, right? Here we observe reflectance. Here we use transmission plus reflectance, and for a transparent food, we use transmittance, right? These are the methods I am not going to explain. So what I wanted to explain is characteristics of color, how to measure color, right? There are 8 characteristics I am going to discuss with you. These are very interesting, how to measure color. Today I will teach you how to write colors. Okay? The colors is a red color. So light red. So I will explain you how to write the numbers for colors. So therefore it is important. Some people, if you have followed what do you call graphic designing or like courses, they must know. For others, you all can understand these characteristics: hue, value or luminance, vivid, shade, tint, tone, brightness you are familiar with, intensity. So first characteristics is hue. Hue means hue is actually a color, the quality by which we distinguish one color from another. කොහොමද අපි එක color එකක් අනිත් color එකේ වෙන් කරලා හඳුනා ගන්න කියන එකට අපි we call it as hue, right? Hue refers to a specific wavelength of color. It is based on the color wavelength, and it's typically described as a name of the pure color. If it is red means it's the hue, yellow means it's hue, right? However, this dimension does not tell us whether the color is dark or light, strong or weak. The hue means the pure color. We cannot get any idea about its brightness, its lightness, its darkness. We cannot get an idea. It merely refers to some point of the spectrum of the colors, such as we have seen in the reflection of sunlight through the prism. Prisme එන colors ටික විතරයි අපි use කියලා ගන්න. Red, yellow, green, blue, purple, red. Purple, sorry. Colors 5, right? How many hues? There are 5 hues, right? You know, red is 1, yellow 3, green 5, 7 blue, 9 purple. We refer here the Munsell color chart. Professor Munsell is the person who has developed this color chart. So how many hues? There are 5 hues. It is based on specific, it is based on the wavelength, and we don't, there is no way to get an idea about its brightness or darkness. You can see how we are going to use this color chart, right? Starting from red, these colors, again red means these are circles, right? The first Munsell color chart, this is the first one. The second one we are going to use for value, we will discuss. Then according to the Munsell color chart, you can see for red he has given number 1, and for the purple he has given number 9. Here you can see 5R, don't forget about the values. R means red, and then purple. Then 5 hues are there. Then for red you have 9 categories. 10 categories, right? For each hue we have 10 categories. Or centimeter, millimeter wage tamai, right? We have different classifications, right? Then how to write this color here? 8R. We always use Munsell color chart for hues from left to right. මේකේ මේ පැත්ත නම් මේ පැත්තට විතරයි අපි කියවන්නේ. හරිද? නැත්තම් වරදිනවා. Please remember, we always use left to right. For example 1, this is 8, value 8. මේ පැත්ත නම් කියවන්නේ ඉතින් මුලින්ම තියෙන red 8R. The second example 9, මේ පැත්ත තියෙන G. Third example, the value is 7.5. The color is purple. right? So P. Can you remember? Understood? How to write colors? තේරුණාද? තේරුණාද? අපි ඊළඟට යමුද? Do you need further clarification, further explanation? Okay, it seems no questions, right? Range of 5R. 5R කියන්නේ මේ color red color එක. ඒතර ඒකේ තියෙන range එක. As we have discussed, there are several characteristics based on tint, brightness. So there are so many colors. The second one, value, luminance. How to write it? You can see here value. So hue is there, value is from here to here, and the third one, chroma, we will discuss chroma from here to here. Right? Value means the quality by which we distinguish light color from a dark color. If it is a light, number is 10. If it is a dark, number is 0. Right? Since pure black is unattainable, the value is 0. The scale begins with darkest gray. Darkest gray එකට තමයි 1 කියන්නේ, black කියන්නේ 0. හරිද? 9 for lightest gray. And 10 means white. Pure white, which is also unattainable, score 10. Therefore, there are 9 steps. And the middle value is 5. Use photometer to detect luminance. We use photometer basically. Orange color means 2.5 YR6. 2.5 YR කියන්නේ මෙන්න මෙතනනේ. YR 2.5. This means here YR, it's orange. 6 means its value. ඒ කියන්නේ මෙන්න මේ හරිය තියෙන්නේ orange color. තේරුණාද? Right. Then now you know 2 steps how to write the hue and value or luminance. Then you just remember these values, right? Then what is red, what is green. So if somebody calls it is 9R, then you should have understanding about the color. If it is a green color or blue color or red color, right? Then chroma අපි ළඟට කතා කරන්නේ vivid. The third one, as we have discussed, from here to here. දැන් අපි curve එක කතා කරා, hue එක, and from here to here value. And third one, chroma, from here to here. Last to, not last, but here when we discuss it chroma, then it is complete, right? Chroma is dependent degree of color from neutral color to the same value. You can see chroma, neutral value to. Color of low chroma are sometimes called weak, while those high chroma called highly saturated or strong. Vivid is the purity of color. Chroma vid, very simple. So how to write the value again from here to here, right? These are the values, right? These are the values. Summarize values. Then Munsell color system. Here you can see the example 7.5B. 7.5B කියන්නේ hue එක. Then 2.8 කියන්නේ value. 2 කියන්නේ chroma එක. Right? Right? එතකොට chroma එක ලියන්න මෙහෙම ඉරක් දාලා. Right? How to write this color? You can understand the color. You should have an idea about the color. If it is 7.5, right? 7.5. 7.5 B. B means blue. 7.5 means here, right? And 8 8 means value. So it's almost light color, ne? Very close to the white, ne? So light color. So 2 kyanne chroma එක. You can observe if it is a chroma from here to here. Ne? From here to here kyanne light color. This is actually original color. Right? There is a request for chroma. So chroma means wheat. Chroma wheat කියන්නේ දැන් මෙන්න මේ පැත්තට color එක දෙකනේ. Saturation එක. අපි කොහොමද බලන්නේ? Right? ඔයගොල්ලෝ පේනවනේ මේ for a particular color, for blue color, from here you can see what is the color. Right? Saturation එක. It means from number 1 from here 1 නේ. So 1 කියන්නේ weak එකක්. ඒක weak blue. Right? මෙන්න මේ color එකක්. So මේ පැත්තට එනකොට you can see red. For red you can observe if it is value 9 here, sorry 5, value 1, you can see the color. That is only the you can get an idea. Okay. Now you have very good idea about colors, I suppose. So please do some examples. Right, your own examples you can do. But the thing how to write, the writing pattern is important. And first we write hue, then value. The last one we use chroma. Okay. And the Munsell color system, you can see different colors. 5 RP, 5 likewise 7. You can observe. Then please do these examples. Homework, right? Whether the make colors or examples and shade, tint, and tone. Shade, tint, and tone, right? Shade means base color plus black. Tone means base color plus gray. Tint means base color plus white. If the tint එක වැඩි වෙනවා කියන්නේ, you know it is moving to the light color, right? Both shade and tint are mixing result of original color to which has been added black and white. Right? A shader is darker than the original color, while a tint is lighter than the original color. කියන්නේ tint කියන්නේ original color එක white mix වෙනවා. If it is more tint, it means more light. If it is more shade color, it means more black is there. It means more dark. If it is more tone, you know, base color plus gray. Understood? The brightness, it is available in your mobile phones, right? It's lightness of the color. I'm not going to explain. You have an idea about the brightness, right? When we increase the brightness, you can see the color. With lower brightness, 40% is somewhat darker, 94% somewhat light, right? Got it? Then the intensity is it's a purity of the hue. What is the hue means? A particular color. There are 5 hues we have discussed. Also called as chroma or saturation, refers to brightness. A color is at full intensity when not mixed, right? So pure color high intensity. If we mix some colors, it means there is a mixture. So intensity is the purity. Low intensity, high intensity, you can see here. That's over. So any question regarding the colors? Please practice how to write the colors today, right? Otherwise, we can practice karana natta ogolla mataka weyi. over the colors ලියන්න. It is important. The next day we are going to do some calculations, right? Based on these color measurements. Then if I ask 7B, 7G, you have to have a good understanding on colors. So let's stop for today. Suppose you have learned a lot. And if others, please ask others to join the next day. I will share the link with you. So thank you very much for joining, and I will wind up the session today and upload the recording to the LMS and YouTube. Great.